Okay, welcome back here to 10. Okay, so we're always going to assume that we have two triangles. Until we prove otherwise, please assume it 8's across from the angle. We always put this other side on the left. Always draw them like that. Angle on the bottom left-hand corner. Here's the opposite side. The third side they give you is up to the left, up from the angle. Draw this one and draw this one every time. Like on the last problem, when this one didn't exist, then this one didn't either. Okay, on this one, if that one doesn't exist, there'll be no solution. If this one exists, we'll have to test to see if that one does. If this one exists too, we got two triangles, we got to solve them both. Okay, so let's go over here with x. I need sine 34 over 8 sine x over 13. Cross multiply 8 sine x sine 34 divided by 8. Takes the inverse sine of both sides. We want to take the inverse sine and that's going to give me whatever x is. If it exists. Now it's possible that it doesn't exist. It didn't exist on the last one. Okay, let's see. Let's do second sine 13 sine 34, close that, divide by 8, close that. Let's see if it exists. Oh, look, it existed. So let's come right here and write it. There's your x degrees. 65, 32, 47, 32, 13 degrees. No rounding. Okay, let's see. I could subtract these two from 180 and get that one. That sounds like a calculator issue. Let's just go grab it. There's that third angle. 80. 6, 7, 5, 26, 787. Now I have everything except side y over here. So I can do sine of 34 over 8. Sine of 80.67526,787 over y. Multiply those two, divide by this one, about 8 sine that one, divide by sine of 34. Aha, y equals 14,117,28741. 14,117,28741. Now let's make sure that that's actually correct. Okay, so let's test this. Sine of 34 divided by 8 is that decimal. Let's go get that angle. Sine of the 65 one divided by 13. Those decimals are matching, so that's good. And then the sine of the 81 and divide it by the 14 one. And look, I got the same long decimal all three times. And those numbers were all on my calculator. I didn't have to recopy anything. Okay, So the first triangle is done. And now we've got to deal with this second one. Okay, so let's call this z degrees, whatever it is. Okay, x degrees, x and z are supplementary. So if you want to find z, all you have to do is take 180 and subtract that 65 number. Let's go find it. There it is. And that's this angle, 114,675, 2679. Now these two didn't go over 180, so this triangle probably exists. So let's see, 180 minus the 34 minus this angle. There's the angle at the top. This angle's 31, 324, 7321. That one's up there. So that's good. And this second triangle is almost solved. We subtracted this one from 180 to find that one. Then we subtracted these two from 180 to find this one. Boy, this second triangle, we've got all three angles and we've got two sides. I just need to find side W over here. I just picked W out of the air. How about sine of 34 over 8? And the sine of 114.675, 2679 over 13. Multiply. Whoa. Can't use that angle, can I? Silly me. I want the one across from W. I want this other angle up here at the top. 31, call myself 32. 47321. Multiply those two, divide by that one. Silly me, I wasn't even going to have a variable in there. How about 8 sine? Oh no, I pressed clear. That's okay. There's the angle I want right there. Divide by sine 34. Watch that pressing clear, you'll cause yourself some grief. And W is 7,437, 68947. Okay, and let's test this one too. But it's going to be that same. Think about this. These are all going to turn out to be the same decimal. It's going to be that decimal right there. So I need sine of the 114 number. Where is it? There it is. Let's divide that by 13. This is going to be the same decimal. And then let's do the sine of the 31 number. There it is. Let's divide that by the 7-point number. Whoa. I don't know what I did right there. And then I get the same decimal all three times. So both triangles are correct. So always double check these on test day. And you should be fine on that one. And there's 9 and 10. And we'll